The ocean, vast beyond comprehension, has always been a boundary between the known world of sunlight and the unimaginable world of darkness. Its surface, restless and glittering, reflects the sky and distracts from the truth that lies beneath an immensity so deep, so uncharted, that it becomes less a geographic feature and more a cosmic expanse folded onto the Earth. Modern satellites have mapped the surfaces of distant planets with greater precision than the floors of Earth's own seas. This disparity is not merely ironic, it is revealing. It tells a story of inaccessibility, of pressure and darkness, and of a realm that resists human intrusion by its very nature. Below the last finger of sunlight exists a frontier shaped not by emptiness, but by pressure, massive, crushing, unyielding pressure. With every meter of descent, the weight of the world accumulates. At 1,000 meters, it is enough to collapse steel. At 10,000, it becomes something so absolute that matter itself behaves differently. The Hadal Trench is named after Hades. The ancient realm of the dead plunged deeper than Mount Everest rises. Inside them, warmth fades, color disappears, and life persists through adaptation so extreme that each new discovery forces science to redraw the limits of what is biologically possible. Yet even with some of the world's most advanced exploration vehicles, accidental discoveries remain the norm. Scientists venture into the deep with defined objectives, mapping, sampling, observing, and more often than not, they return with anomalies, hints, echoes of something else. Marine research logs across decades are filled with notes that seem almost peripheral. Unexplained sonar distortions, biological traces without clear origin, optical fragments of shape and movement not corresponding to any cataloged species. These fragments accumulate like dust in the corners of human knowledge, forming patterns only visible when one steps back and considers the collective history of deep-sea observations. The ocean offers no easy revelations. It reveals itself only in flashes, brief, often unreliable glimpses, like lightning illuminating a storm-swept landscape. Still, it is within those brief openings that the most remarkable discoveries occur. The first of the 5 accidental encounters that reshaped modern understanding of deep-sea biology began near the Tonga Trench, one of Earth's most violent and tectonically active regions. Seismic surveys launched to investigate unusual tremors beneath the seafloor had been planned with the precision typical of geophysical research. Deploy mapping drones, record data retrieve equipment. Nothing in the operation involved biological study. The team expected the routine vibrations of crustal movement, not the unexpected heat signatures that began appearing on the instruments. The anomaly manifested as a sinuous thread of thermal energy, cutting across an otherwise frigid region. At first, the scientists assumed equipment error. Deep trenches rarely host significant heat sources, except for hydrothermal vents or tectonic rifts, and the trench section being surveyed contained neither. Yet the anomaly moved slowly, deliberately, like a drifting current that defied the patterns of any known oceanographic flow. Temperature readings fluctuated in a rhythmic pattern, rising and falling as though generated by muscle contractions or metabolic pulses. When optical imaging attempted to capture the source, the cameras returned frames filled with darkness, static, and brief wavering lines of faint light. These lines were not reflections from instruments. They curved and twisted, independently reacting to unseen stimuli. The technicians increased exposure times, trying to coax structure from the glow. In several frames, the light formed an elongated shape, segmented and undulating, as if part of a transparent body larger than the visible portion. Later analysis would classify these luminous distortions under a provisional label, anomalous rift organism 01, though the scientists on site gave it a more evocative name, the luminous rift serpent. Its description, pieced together from dozens of partial detections, portrayed a creature unlike anything in existing marine taxonomy. Its body appeared to consist of translucent ribbed layers through which internal bioluminescent organs pulsed with soft blues and greens. The light was not constant. It flickered like distant lightning trapped beneath gelatinous skin. The organism seemed to use this glow not merely as a lure, but as a functional component of navigation within the pitch-black trench. The sonar readings were even more unsettling. When the creature moved, it did so with extraordinary fluidity, bending in coils that spanned tens of meters. But it also moved in abrupt bursts, predatory lunges too fast and too coordinated to be a drifting invertebrate. These bursts left streaks in the acoustic logs, deep arcs indicating sudden acceleration. The arcs ended in zones where smaller heat traces disappeared completely, suggesting that the serpent was feeding. The most striking evidence came from a fragment of tissue inadvertently collected when a mapping drone ascended too closely to the serpent's path. The drone later surfaced with a smear of iridescent material on its hull, thin, fibrous tissue that shimmered with bioluminescent residue. Analysis revealed a complex biological structure, flexible collagen-like matrices, reinforced with mineralized strands capable of withstanding immense pressure without losing elasticity. Moreover, the tissue contained unique photophores, whose glow persisted faintly even after isolation, hinting at a biochemistry not yet understood. No conclusive morphological image of the creature exists. The deep obscured more than it revealed. The serpent moved within a world that swallows light and bends sound, making observation nearly impossible. But it was the movement, the thermal signature, and the predatory behavior that forced researchers to reconsider assumptions about the deep trenches. The Hadal zones, once thought to be sparsely populated by simple pressure-adapted invertebrates, now hinted at the presence of complex predators large enough to leave signatures comparable to medium-sized whales. The discovery of the luminous rift serpent was accidental, brief, and incomplete. Yet it became the first thread in a tapestry of evidence suggesting that Earth's deepest places harbor organisms more extraordinary than imagination has allowed. The deeper one descends into the Hadal environment, the more apparent it becomes that human intuition fails to function there. Concepts such as proximity, scale, and movement lose relevance in the distorted geometry of the trenches. Light does not travel far, sound refracts unpredictably. A creature could pass meters away from a camera without ever being seen, while something kilometers distant might produce acoustic signatures so intense that they mimic nearby motion. It is within this uncertainty that organisms like the luminous rift serpent thrive, shaping their existence around a sensory world entirely unlike the human one. The Tonga Trench had long been considered a region of relative biological quiet, at least compared to hydrothermal vent ecosystems or shallow pelagic zones teeming with life. But the serpent's appearance revealed a truth that marine biologists had speculated about for years. Deep tectonic environments may serve as migratory channels for megafaunal organisms unknown to science. The unique combination of geothermal warmth, slow-moving currents, and mineral-rich outflows provides conditions capable of supporting large lifeforms, even if those forms remain hidden from direct observation. Subsequent expeditions attempted to rediscover the serpent, but the deep is an unstable place. Tremors shift seafloor geometry, altering trenches like rivers, rewriting their courses. The serpent's thermal trail vanished within days of its first detection, leaving only data logs and the enigmatic tissue fragment behind. Researchers scrutinized these artifacts, hoping to extrapolate the serpent's physiology, but everything remained speculative. What little could be confirmed only expanded the mystery. The photophores, still faintly luminous, even in controlled environments, contained layered vesicles that emitted light through chemical reactions not documented in any known species. These vesicles appeared able to alter both intensity and wavelength, implying a complex communication or hunting mechanism. Biologists debated whether the serpent used this light to dazzle prey, navigate tight trenches, signal others of its kind, or even camouflage itself by mimicking fault-line glow patterns. Each possibility implied ecological sophistication on a level previously attributed only to shallow-water cephalopods or certain bioluminescent fish. Equally enigmatic was the tissue's structural composition. The mineralized strands exhibited flexibility under extreme pressure, but hardened when depressurized, forming brittle filaments that fractured with crystalline patterns. This suggested an adaptive material, something capable of shifting between rigidity and pliability depending on environmental conditions. Such an adaptation could allow the serpent to brace itself against trench walls or anchor during high turbulence events, preserving energy. The discovery triggered a wave of new hypotheses regarding deep-sea megafauna. If one such organism existed, how many others remained unseen? How many evolved in parallel, utilizing tectonic rifts as migration routes or feeding grounds? These questions reshaped the framework of Hadal biology, expanding it beyond the microscopic and the scattered into the realm of the massive and the sophisticated. Yet the serpent was only the beginning. The scientific community, enthralled by the implications, began re-examining decades of archived data from oceanic surveys worldwide. Patterns emerged, subtle, easily overlooked, but undeniable in retrospect. Across multiple trenches, sensors had recorded brief anomalies similar in structure to those found near Tonga: shifting thermal ribbons, rhythmic fluctuations in background light, irregular sonar echoes consistent with large flexible bodies. These anomalies formed no coherent map, but together they hinted at a global presence of organisms occupying deep tectonically active regions. It was no surprise then that the serpent's case rekindled interest in an older mystery one documented nearly 2 decades earlier during a geological expedition in the Western Pacific. The expedition's logs described similar irregularities detected at extreme depths, though at the time they were dismissed as equipment artifacts. Reviewing them with the knowledge gained from the Tonga serpent transformed them into some of the earliest indirect evidence of deep-sea megafauna. The serpent's discovery also encouraged interdisciplinary collaboration. Geologists once primarily concerned with fault lines now worked alongside marine biologists and biochemists. Acoustic engineers studied the movement-induced disturbances, trying to reconstruct the serpent's locomotion patterns through sonar mapping. Even astrophysicists offered insights comparing bioluminescent signatures to energy distributions found in extreme extraterrestrial environments. The interdisciplinary approach yielded a broader understanding of deep-sea ecosystems. Far from barren, these depths appeared to function as self-sustaining environments, shaped by complex energy transfers not reliant on sunlight. Chemosynthetic bacteria, thriving on minerals from tectonic activity, formed the base of food webs that supported increasingly larger organisms. The serpent's existence implied that these food webs might be far more robust than previously assumed, capable of sustaining predators hundreds of meters long. As researchers pieced together the serpent's ecological implications, one question loomed: was the Tonga sighting a solitary encounter with a rare species or a fleeting glimpse of a broader population? Some argued that such a creature must be rare given the scarcity of direct observations. Others countered that rarity of observed evidence did not equate to rarity of existence. The deep is vast enough to conceal entire ecosystems indefinitely. A population of even a few hundred individuals roaming between trenches could remain undetected for centuries. A more radical hypothesis suggested that the serpent might not have a fixed population size at all. It might be a long-lived organism with a lifespan spanning hundreds, perhaps thousands of years. Extreme longevity, while unprecedented on such a scale, could be theoretically supported by the deep sea's low temperatures, slow metabolisms, and stable chemical environments. If true, then the serpent might represent not a species, but a lineage, individuals passing through the deep like solitary titans shaped by epochs rather than generations. The Tonga serpent became a symbol of the unknown, a biological ambassador from a realm beyond ordinary comprehension. Scientific papers referenced it with cautious neutrality, while public imagination transformed it into a creature of legend. But legends, no matter how embellished, often arise from slivers of truth. And this truth was simple. Something enormous, luminous, and predatory had moved through one of Earth's deepest trenches, leaving behind only fragments of itself and countless unanswered questions. This first discovery redefined what scientists believed the ocean depths could conceal. But it was only the opening chapter in a series of revelations that would continue to unfold unexpectedly across the world's most remote underwater frontiers. In the months following the Tonga expedition, attention shifted toward a different kind of analysis, one that looked beyond direct evidence and into the patterns hidden within the ocean itself. For decades, oceanographers had recorded subtle inconsistencies in deep water circulation models, anomalies that seemed too structured to be random but too fleeting to classify. Now, with the serpent's appearance fresh in scientific memory, these anomalies were scrutinized anew. The first clues came from deep current displacement charts. In several trenches, instruments had captured disturbances that resembled the wake of a large elongated object moving at considerable depth. These disturbances were not typical of geological activity. They lacked the chaotic signatures of rockfalls or sediment plumes. Instead, they displayed coherent, smooth, directional shifts in water density and temperature, as though a massive, flexible body had passed silently through the abyss. Such disturbances were often dismissed as thermal eddies or equipment drift, yet the patterns repeated with surprising consistency across the western and southern Pacific. When mapped together, they revealed channels, narrow corridors of disturbed water stretching across hundreds of kilometers, linking separate trenches into a chain of deep pathways. It was a pattern reminiscent of migratory routes, though at a scale vastly larger than that of any documented marine species. This raised a new and unsettling possibility. The creatures like the serpent might not be isolated to a specific trench, but instead traveled through an interconnected network of deep fissures spanning entire ocean basins. These were not ecosystems in isolation, they were components of an immense hidden world beneath the crust of human understanding. This concept challenged long-standing assumptions about hadal habitats. Traditional models described trenches as extreme isolated pockets of life, biological islands with little cross-communication. But the emerging evidence suggested the opposite: trenches might serve as nodes within a larger biological system, with megafaunal species moving between them, in patterns shaped by tectonic geography and deep water currents. If true, then creatures like the luminous rift serpent could roam distances comparable to those of migratory whales, yet remain invisible due to their habitat's depth and their own physiological adaptations. This revelation reframed many past mystery signals detected in deep-sea monitoring stations, signals once attributed to mechanical faults or distant seismic events. Acoustic specialists re-examined archival recordings and identified repeating acoustic signatures that did not match geological origin. Unlike earthquakes or volcanic rumbles, these signals displayed rhythmic modulations, long rising pulses followed by abrupt shifts in frequency. They were faint, often masked by ambient ocean noise, but their patterns were unmistakably biological. Some pulses corresponded in timing and location to the Tonga serpent encounter, suggesting that the organism emitted low-frequency vibrations, possibly for navigation or communication. Other pulses, however, originated from depths far below the serpent's recorded range, hinting at the presence of multiple species with similar but distinct acoustic profiles. This created a tantalizing possibility: the serpent might not be a solitary giant, but one representative of a diverse group of deep-sea megafauna yet to be cataloged. Each species, shaped by the pressures of the abyss, could possess its own unique adaptations: bioluminescent patterns, acoustic signals, thermal signatures, forming a complex ecological tapestry hidden beneath crushing darkness. The research community grappled with the implications. If numerous large organisms existed at extreme depths, why had they never been directly observed? The answer lay in the realities of deep-sea exploration. Most deep-diving equipment suffers from limited mobility and restricted field of view. Remote vehicles illuminate only small cones of light, leaving the surrounding darkness untouched. Sonar can detect movement, but cannot reliably reconstruct fine anatomical detail. Additionally, the deep sea's immense scale makes targeted exploration nearly impossible. The hadal trenches cover areas comparable to continents, their floors broken by ridges, valleys, and geological formations that create labyrinthine terrain. A creature could pass within tens of meters of a remote vehicle without being seen, its presence revealed only by subtle shifts in water temperature or fleeting distortions in sonar. The serpent, with its translucent body and adaptive light patterns, was likely a master of remaining unseen, navigating the deep with senses evolved to exploit the very limitations that hinder human observation. The possibility of deep megafauna moving across tectonic networks led researchers to revisit reports from remote monitoring stations situated in other ocean basins. Deep Atlantic sensors had recorded similar anomalies: thermal ribbons, faint bioluminescent flashes, inexplicable acoustic pulses, though these were never previously linked to living organisms. If these events were related, they indicated a global presence of such creatures dispersed across every major trench system on Earth. The discovery also forced a re-evaluation of biomasses estimated for the deep ocean. Current models suggested that only small organisms could survive at hadal depths due to limited energy sources. But if the base of deep-sea food webs was stronger than assumed, fueled by mineral-rich waters, chemosynthetic colonies, and tectonic byproducts, then the entire system could support far larger predators. Recent ventures into trench ecosystems had revealed sprawling microbial mats, immense tubeworm clusters, and unexplained concentrations of biomass far from known vents. These findings hinted that the deep might contain pockets of productivity previously hidden from scientific analysis. Within these pockets, megafaunal species could thrive, feeding on ecological chains sustained by geological energy rather than sunlight. The serpent's detection at Tonga may have been a statistical anomaly, a moment when one of these deep giants intersected with human technology. But just as likely, it was a glimpse into a vast unseen world operating beneath tectonic boundaries and beyond human sight. A world where pressure replaces gravity as the dominant force, where darkness is pierced only by bioluminescent signals, and where life evolves, forms incomprehensible to surface dwellers. As the scientific narrative expanded, so too did the philosophical one. The serpent became a symbol not simply of biological discovery, but of human limitation. It reminded researchers that Earth itself remains an alien world, its oceans a frontier, as mysterious as any imagined in space exploration. For hundreds of years, humanity has assumed that knowledge expands linearly with exploration. Yet the deep ocean contradicts this belief. The deeper we descend, the more the unknown grows, branching into forms and possibilities that challenge every expectation. The serpent was the first of 5 extraordinary encounters. But even as researchers prepared for future expeditions, there remained an unspoken understanding. The deep reveals only what it chooses, and often only by accident. The discovery of the luminous rift serpent marked only the earliest crack in a vast unseen world. As the scientific community continued to process the implications, researchers from multiple disciplines began reinterpreting the data that for years had been dismissed as background noise equipment errors or environmental interference. What had once been considered meaningless anomalies now appeared to be fragments of a much larger pattern, a structure hidden beneath the waves and built upon forces older than humanity itself. Attention soon turned to the phenomenon known among oceanographers as the shadow zones regions, where sound bends away from sensors and light disappears entirely. These pockets, created by temperature gradients and pressure stratification, function as natural sanctuaries for organisms adapted to avoid detection. Every major ocean basin contains such zones, some spanning hundreds of kilometers horizontally and thousands vertically. Within them, acoustic signals scatter unpredictably and visual detection becomes nearly impossible. For creatures inhabiting these shadowed realms, invisibility is a fundamental survival strategy. Bodies lacking rigid structures absorb sonar pulses instead of reflecting them. Translucent tissues blend seamlessly with the black water. Bioluminescent organs can modulate themselves to mimic the faint background glow of deep rifts. In this world, the serpent's shimmering signals were not an anomaly but a language, one of countless adaptations sculpted by pressure and darkness. Attempts to reconstruct the serpent's physiology using computational models produced conflicting results. Some simulations suggested an organism composed largely of flexible cartilage similar to deep-sea eels but vastly larger. Others indicated a uniquely segmented architecture, granting extreme mobility under crushing pressure. A more radical interpretation proposed that the serpent might not be a single organism at all, but a colony similar to a siphonophore, with multiple specialized units functioning as a collective. This hypothesis aligned with the modular structure visible in the tissue fragment, which exhibited layered patterns unlike any continuous biological structure known to science. Such an interpretation challenged conventional ideas of individuality. If the serpent was a colony, then it represented a type of megafauna capable of remarkable resilience. Damage to a single section would not incapacitate the entire organism. Its distributed photophores could act independently to coordinate movement, lure prey, or navigate tight fissures. The serpent might not age or die in the traditional sense, instead regenerating over centuries through the renewal of its living segments. The implications were profound. A creature built as a modular colony could theoretically survive geological upheaval, migrate through shifting rifts, and adapt over enormous spans of time. It could outlast entire ecosystems and travel distances comparable to those of ocean currents themselves. As new interpretations emerged, researchers noticed that the serpent's appearance coincided with seismic instability near the Tonga Trench. This correlation raised the possibility that deep-sea giants might respond to geological cues. Perhaps they followed heat gradients left behind by tectonic shifts or the chemical traces of freshly opened fissures. Some speculated that the serpent's rare appearance in open trench waters resulted from a disturbance in its usual habitat, forcing it briefly into a region where it could be seen. The team re-examined global seismic records and discovered that several previous anomalies recorded in distant trenches also occurred shortly after tectonic events. The pattern was imperfect but unmistakable. Some of the largest unidentified sonar distortions ever captured had been logged within weeks of deep ocean earthquakes. These distortions shared similar signatures: rapid acceleration, flexible body curvature, and faint thermal pulses consistent with large organisms responding to environmental changes. This raised a question that challenged decades of assumptions. Were the trenches merely environments for deep sea life, or were they also used as migration pathways triggered by tectonic activity? If a network of such pathways existed, then the serpent might be only one of many species navigating them. Unseen over millennia, researchers began mapping the anomalies across multiple ocean basins and discovered something extraordinary. Several of the thermal disturbances traced long arcs across the ocean floor, forming continuous paths stretching thousands of kilometers. These arcs connected trenches, fissures, and rift valleys in ways that implied biological movement rather than geological randomness. The paths resembled migratory routes on land and in shallow waters, but at scales measured not in kilometers, but in entire ocean basins. If correct, then the serpent's path was only one line in a much larger map, a map drawn by the movement of colossal organisms long before humans developed the technology to sense them. The deeper this investigation went, the more it seemed that the ocean was filled not with isolated giants, but with entire communities of megafauna linked through ancient migratory channels. Some might travel seasonally following chemical trails. Others might drift slowly over decades, aligning with deep water circulation. Still others might remain solitary, emerging only when shifts in temperature or pressure forced them into new regions. The idea that such a network existed reshaped modern marine biology. The serpent, once considered an isolated marvel, now appeared to be a representative of a vast hidden world, a world where organisms evolve not in isolation but in coordination with the planet's deepest forces. As researchers assembled these findings, one final realization emerged, a realization both exhilarating and unsettling. Everything humans had seen so far had been revealed by chance. A single tremor, a flicker of instrumental failure, an accidental illumination by volcanic light, these were the only circumstances under which the giants of the deep had ever been glimpsed. What then of the creatures that never crossed into illuminated water, never brushed against a drone, never passed through a sonar beam? What of those that lived deeper still in trenches, narrow caverns, and fissures unreachable by any machine? What of the beings whose entire existence unfolded beyond detection? If the serpent was discovered only because it strayed from its hidden world, then for every one creature glimpsed, there might be dozens, perhaps hundreds, existing in complete secrecy. Creatures shaped by pressures impossible to replicate in laboratories, creatures whose biochemistry defied human instruments, creatures so large, so slow, or so soft that they blended seamlessly with the sea itself. The abyss remained impenetrable, holding its inhabitants in perfect darkness, and it was becoming clear that humanity had only brushed against the edges of a biosphere far larger and older than anything imagined. What lay deeper was not absence, but abundance. The ocean hid multitudes waiting in places where no light could reach, moving in rhythms older than continents held in silence by pressure and time. And so the first chapter of discovery closed with a simple truth, one that would guide all research to come. The deep chooses what it reveals. The rest remains hidden in the endless dark. Life in the deep ocean exists in a realm defined by forces that reshape every familiar rule of biology. At depths where sunlight has never reached, and where the weight of the world rests upon every square centimeter of flesh existence, becomes a negotiation not with predators or competitors, but with pressure, temperature, chemistry, and time itself. The Hadal Zone, stretching beyond 6,000 meters down into the deepest trenches on Earth, is a domain where creatures must either adapt to extremes beyond imagination or vanish entirely. Yet here in this zone, seemingly hostile to life evolution, has produced organisms that thrive with adaptations so specialized and so alien that they challenge the very meaning of survival. Understanding these organisms requires abandoning assumptions shaped by life near the surface. In the deep, there is no light to guide movement or form. There is no stable terrain, no predictable seasons, no spacious habitat where eyes and speed offer advantages. Instead, structures that would be shattered closer to the surface become flexible, fluid, and gelatinous. Skeletons become unnecessary as buoyancy replaces the need for support. Nervous systems disperse across tissues, allowing slow, coordinated responses to the faintest chemical or mechanical cues. Where warm-blooded creatures burn energy constantly, deep-sea organisms conserve it with cold, efficient metabolisms driven by chemistry instead of sunlight. It is within these crushing depths that accidental discoveries have revealed organisms of staggering size and complexity. The luminous rift serpent, the vast creature discovered near the Tonga Trench, was the first to challenge long-held assumptions about what could survive in this world without light. Yet even that finding proved only the beginning. As researchers analyzed decades of archived data, they realized the serpent was only one piece of a larger evolutionary puzzle. Other anomalies in sonar logs, acoustic recordings, and damaged equipment began to align, forming the shape of a deep-sea biosphere teeming with giants. The next major insight emerged from a mission once thought to be a failure. Years before the serpent's discovery, an autonomous mapping drone deployed in the Philippine Trench malfunctioned and was nearly lost. At the time, the mission logs described the incident as the result of unstable currents and unpredictable pressure pockets. But with hindsight and with the knowledge gleaned from the serpent, scientists revisited the recordings and found unmistakable signs of a colossal living organism. The Philippine Trench is among the deepest known places on Earth, reaching depths greater than 10,000 meters. It is a cathedral of pressure, cold, and absolute darkness. Only the sturdiest machines built with thick hulls and advanced sensors can descend into it, and even these machines operate at the edge of failure. The mapping drone in question had been designed not for biological study, but for measuring mineral content and magnetic anomalies along the trench walls. For hours, the drone performed flawlessly, drifting through a world of stillness punctuated only by faint seismic vibrations. Then, without warning, the drone's hydrophones recorded a set of harmonic pulses, faint at first but growing stronger. The pulses repeated at intervals too regular to be random and too deep to originate from surface noise. Each pulse vibrated through the drone's frame, creating a low, resonant hum that caused the cameras to tremble slightly. Initially, researchers attributed the vibrations to distant tectonic movement, but the pattern persisted far too long to match any known geological process. Then the sonar captured something unprecedented, a massive curved shape entering the edge of the scan. It appeared only briefly, a single sweeping ridge followed by a shadow that curved away into darkness. The shape vanished, then returned moments later, accompanied by another harmonic pulse. The drone drifted closer, its sensors struggling to adapt to the low visibility. More curved structures became visible, arranged in a long symmetrical series. They resembled the ribs of some giant aquatic creature or the arches of a submerged instrument. What the drone had detected would later be named the abyssal harpback. The harpback derived its name from the arched structures rising along its dorsal side, each one shaped like the frame of a stringed instrument. These arches varied in size and thickness, and as the creature moved, they vibrated, producing deep harmonic pulses that rippled through the surrounding water. The drone's last clear acoustic recordings captured this resonant song, a mixture of low frequencies and subtle harmonics that no geological event could replicate. The organism did not simply emit sound, it created it with orchestrated precision. As the drone attempted to move past the enormous creature, the harmonic pulses intensified. The arches trembled, causing vibrations strong enough to disorient the drone's stabilizers. Telemetry data revealed that the machine's internal gyroscopic systems fluctuated dramatically, as though caught in a field of distortion. The drone's camera captured a brief but unmistakable image, a massive pale ridge scraping across the lens before everything dissolved into darkness. When the drone was eventually recovered, its hull bore marks of the encounter. 3 long parallel gouges ran across one side, identical in spacing to the harpback's largest arches. The damage was not the result of aggression, but of proximity contact between the drone and an organism so large and so seldom detected that the very idea of collision seemed unreal. The harpback's arches served not merely as biological adornments, but as sensory and communicative devices. Researchers studying the acoustic recordings noted patterns suggesting that the creature used resonance for navigation, much like bats use echolocation, and whales use low-frequency calls. In the deep trenches where darkness reigns, sound becomes the most reliable medium for sensing surroundings. The harpback appeared to have evolved an entire symphony of vibrations, allowing it to interpret the shape of trench walls, the presence of prey, or the movement of distant organisms. This discovery expanded the scope of what deep-sea life might be capable of. The serpent used bioluminescence and fluidity. The harpback used resonance architecture and vibration. One creature thrived in narrow rift corridors, the other in open trench basins. Together they represented a diversity at odds with long-standing beliefs that deep-sea life must be uniform, simple, and small. Yet the harpback was not the only giant waiting to be discovered. Another creature lurked within a collapsed hydrothermal cavern submerged in the depths of the western Pacific. The cavern had been the site of a geological survey intended to document mineral formations left behind by extinct vents. As an unmanned submersible drifted deeper into the cavern's narrow opening, its sensors picked up distortions in the magnetic field. These distortions pulsed rhythmically, like the beat of an unseen organ. Cameras adjusted, but the interior remained cloaked in absolute darkness. Only when the submersible activated its external lights did the cavern reveal its inhabitant. A massive eel-like figure coiled upon itself, pale and skeletal in appearance, lay resting across the cavern floor. Its surface gleamed faintly like polished bone. This was the pale cathedral eel, named for the tall, vaulted cavities rising from its head resembling the arches of a cathedral. These cavities housed complex internal lattices capable of amplifying electromagnetic signals. The eel did not rely on vision or sound. It sensed the world through magnetism, detecting the faintest disturbances from meters or even kilometers away. As the submersible approached, the eel stirred. Its cranial ridges vibrated, creating a field strong enough to disrupt the submersible's instruments. Navigation systems faltered. Compass readings spun wildly. Cameras flickered. The eel did not strike or show aggression. It simply asserted its presence through electromagnetic force, a territorial warning delivered without movement or violence. The cavern in which the eel rested bore evidence of long-term occupancy. Mineral walls were polished smooth in places where the creature had pressed its body over years. Patterns etched into the stone hinted at repeated oscillations of its cranial structures. Sediment beneath its coils had compacted into layers, revealing that the creature often returned to the same resting position. It was not a hunter roaming vast distances, but a guardian maintaining careful control of a micro-ecosystem built around lingering geothermal heat. The cathedral eel presented a new model of deep-sea existence, an organism not built for speed or migration, but for dominance over a small, stable territory. This presented a striking contrast to both the serpent and the harpback, suggesting that deep ecosystems contain not only migratory trails and feeding corridors, but also sanctuaries where solitary giants may persist for centuries. By the time researchers completed their analysis of the eel, they recognized a truth more expansive than any single discovery. The deep sea did not hold one path of evolution, but many. It was a world large enough, ancient enough, and varied enough to support entire categories of megafauna, each with different strategies. Some roamed, some resonated, some blended into shadows. Some guarded the stillness of sheltered caverns. The giants of the deep were not isolated marvels. They were part of a network older and broader than human science had ever considered. And the next discovery, waiting in the volcanic zones of the Pacific, would reveal a creature unlike anything seen before, a being shaped not by pressure or darkness alone, but by fire itself. The volcanic arc, where the next discovery occurred, lay thousands of meters below the surface, in a region where the seafloor cracked and heaved with constant geological tension. Unlike the cold stability of the trenches, volcanic zones were chaotic landscapes sculpted by molten rock erupting from deep fissures. These eruptions created temporary sources of heat that spread through the dark waters like underwater storms, illuminating fragments of the abyss with momentary flashes of red and gold. Life here did not simply endure, it adapted to unpredictability, thriving in chemical gradients that shifted without warning. Into this hostile environment, an unmanned submersible descended during a routine geochemical survey. Its mission was simple: measure temperature flows, sample ash, and gather data from plumes rising from newly opened vents. The machine drifted through clouds of black ash and shimmering water, its lights carving tunnels through the murk. But the camera soon captured shapes that could not be explained by geology, twisting shadows that appeared and vanished as the water flickered with volcanic light. At first, researchers assumed these shapes were turbulence distortions, but as the eruptions grew brighter, they revealed a colossal form hidden in the drifting ash. It was immense, dark, and fluid, shaped like a sweeping membrane pulled taut across invisible structures. For an instant, the creature reflected the red glow of molten rock, and its surface shone like polished obsidian. Then the ashes swallowed it again. The submersible advanced, cautiously circling the plume's edge. Each time the volcanic glow surged, the creature's shape reappeared, revealing more details. Its body was not solid like that of the serpent or eel, but a vast flowing sheet, a mantle spanning as wide as a building. The membrane rippled in slow waves, shifting colors across its surface. Flickering chains of light ran along its edges, patterns produced by mineral-rich chromatophores embedded in its skin. This was the obsidian mantle. Its shape resembled an enormous deep-sea cephalopod, but without defined arms or a central head. Instead, its entire body was a single expansive surface, flexible enough to coil around rock formations or ride volcanic plumes upward. Unlike normal oceanic creatures, the mantle thrived in heat. Its tissues incorporated mineral structures similar to volcanic glass, granting it extraordinary resistance to both temperature and pressure. The submersible observed the mantle hunting. When a surge of chemical-rich water flowed from a vent, it stirred clouds of microorganisms and attracted small crustaceans and gelatinous fish. The mantle drifted into the plume, folding parts of itself around the prey. Thin, nearly invisible tendrils extended from its underside, sweeping organisms into hidden siphoning chambers. These chambers remained unseen, but their presence was clear. The water around the mantle cleared rapidly as prey vanished into its body. Most remarkable was the creature's reaction to volcanic activity. When magma approached the seafloor, it produced subtle vibrations and chemical cues. The mantle sensed these signals and moved before eruptions occurred, positioning itself in the safest location and using the upcoming blast to illuminate prey or travel along heated currents. Its chromatophores shifted rapidly, producing shimmering waves of color that seemed to redistribute heat across its surface, preventing damage even when exposed to near molten temperatures. During one eruption, the submersible recorded the mantle unfurling its full width. In the sudden brilliance of molten light, the creature expanded like a dark-winged titan, its membrane stretching across tens of meters. The visual was breathtaking, a living sheet of obsidian rippling with volcanic reflections. When the light faded, it collapsed back into shadow, moving with ghost-like grace. The mantle forced researchers to redefine yet again what adaptation meant in the deep. The serpent had evolved transparency, the harpback resonance, the cathedral eel electromagnetic perception. Now the mantle revealed adaptation to fire a creature using heat itself as both shield and guidance. But the deep had not yet exhausted its capacity for revelation. Another organism awaited discovery, not in volcanic chaos or in caverns, but in the open abyssal plains where nothing of interest was ever expected to live. It was found during a current mapping operation near an unremarkable trench slope. The probe drifted across what seemed like a stable plain of sediment. Then its sensors detected a shadow so large it appeared to stretch for nearly 100 meters. The shadow moved, but so slowly that its motion registered only over long intervals. At first it resembled a shifting dune or a submerged ridge, but the shape undulated ever so slightly. The ocean floor itself was alive. As the probe lowered its lights, a vast fleshy surface came into view, covered with gentle ridges and channels. Microbial colonies glowed faintly along its length, creating constellations of blue and green. Small crustaceans scrambled across the colossal surface, unaware of the observer above. The giant did not react to the probe's presence. It moved with glacial slowness, dragging itself through sediment in a motion almost indistinguishable from geological drift. This was the Hadal trawler. It stretched across the seafloor with a body so broad and slow that it was nearly impossible to distinguish from terrain. Unlike predators, it was a grazer feeding on sediment microbial mats and chemical-rich particles. It drew nutrients through vast channels running along its underside, pulling in water and silt, filtering them through labyrinthine internal surfaces where chemosynthetic bacteria thrived. These bacterial colonies acted like agricultural fields, cultivated indirectly by the creature's constant slow movement. The trawler reshaped the ocean floor as it moved, leaving long, smooth tracks hundreds of meters in length. Sediment overturned by its passage revealed fresh layers enriched with nutrients. Entire ecosystems followed in its wake, drawn to the disturbed earth. In this way, the trawler became not only a consumer, but a gardener of the abyss, sustaining smaller organisms that depended on its vast presence. Its physiology defied categorization. It had no clear head or limbs. Instead, its body was a distributed network of tissues working collectively through slow chemical communication. Neural clusters scattered through its mass-coordinated movement and feeding without a central brain. Damage to one region barely affected the whole, allowing it to endure centuries of existence. As more data from the probe was reviewed, researchers realized the trawler was not unique. The tracks across the abyssal plain indicated multiple individuals, or perhaps generations following ancient migratory circuits. These circuits traced arcs and loops across thousands of kilometers, implying a species that treated the vast seafloor as a pasture, tended slowly over millennia. The discovery of the trawler completed a pattern. The deep-held predators, navigators, guardians, fire-dwellers, and grazers, each filling an ecological role in a world nearly devoid of sunlight, yet rich in geological energy. The deep trenches, caverns, volcanic arcs, and plains formed interconnected biomes populated by giants so well adapted that they had lived for millions of years without detection. With 5 giants revealed by accident, scientists understood that these discoveries were only the beginning. For every organism glimpsed, countless others remained hidden by shadow, pressure, and distance. The deep ocean continued to guard its secrets closely, revealing them only when chance allowed, and withdrawing them again into the endless dark. The discoveries of the luminous rift serpent, the abyssal harpback, the pale cathedral eel, and the obsidian mantle forced scientists to reconsider the foundations of deep ocean biology. Each organism had revealed not only its own existence, but an entire category of adaptations shaped by the extreme environment of the Hadal world. Yet none of these discoveries prepared researchers for what emerged next. The 5th organism, the largest and most enigmatic among the deep-sea giants, challenged every remaining assumption and pulled the focus of oceanographic science away from trenches and volcanic rifts and toward the vast plains of the abyss themselves. To understand this giant, scientists first needed to confront the nature of the abyssal plains. These regions, stretching across thousands of kilometers, are some of the most stable and least dynamic environments on Earth. At depths of 4,000 to 6,000 meters, the plains are coated in soft sediment known as marine snow, composed of microscopic detritus sinking gradually from the surface. For decades, biologists believed these plains to be nearly barren home, only to scattered worms, crustaceans, and sluggish fish surviving on sparse resources. This view began to shift when researchers observed unusual patterns in sediment distribution. Satellite-linked sonar had detected long, sweeping arcs on the sea floor, some stretching for kilometers. These arcs were too smooth to be geological faulting and too continuous to be created by current-driven drift. Their presence resembled the marks left by something moving across the sediment with incredible slowness. At the time, these patterns were dismissed as artifacts of scanning. That assumption did not survive the discoveries that followed. The clearest evidence emerged when a current mapping probe drifting through a remote section of the abyssal plain recorded an anomaly beneath it. The probe's sensors detected a mass so large that its boundaries extended beyond the range of the imaging system. The machine hovered, adjusting its altitude. Only then did its main camera reveal that the plain below was not merely sediment, it was a body. What the probe had encountered appeared at first to be a vast textured surface. It rose and fell with a slow, steady rhythm almost imperceptible. As the probe lowered its lights, the surface gleamed with a faint sheen, revealing subtle folding patterns that could not be explained by sediment layering. Microbial communities glowed faintly across it, indicating biological activity. When the probe drifted sideways, the surface changed contour, confirming beyond doubt that it was alive. The entity came to be known as the Hadal trawler. The trawler's body spanned tens, perhaps hundreds of meters. Its width resembled the hull of a sunken ship embedded in sediment, yet flexible enough to ripple gently as it moved. The creature advanced by slowly contracting broad sections of its underside, dragging itself across the seafloor. These contractions disturbed sediment, lifting clouds of particles into the water, which the trawler then filtered for nutrients. This feeding method transformed the creature into a living harvest machine, combing the ocean floor 1 meter at a time and extracting life-sustaining material from the deep. Its upper surface formed a landscape in miniature. Ridges, valleys, and channels crisscrossed its width, each supporting microbial ecosystems that thrived on the nutrients the creature carried. Small crustaceans and scavengers could be seen crawling across its back, feeding on the organic matter trapped in its tissues. To them, the trawler was not merely an organism, but a mobile habitat, a drifting continent in a world of darkness. The probe's footage showed an astonishing degree of biological integration. The creature's tissues pulsed with slow waves, distributing nutrients and chemical signals across its vast body. No single head or central structure guided its movement. Instead, a distributed network of neural clusters coordinated sections of its anatomy, much like the decentralized control seen in jellyfish and colonial organisms. This made the trawler extraordinarily resilient. Damage to any one area had little effect on the whole, and individual regions could adjust autonomously to local conditions. It became clear that the trawler was not a predator, but a grazer and an environmental engineer. As it moved, it overturned sediment, exposing buried layers to oxygenated water and redistributing microbial life. The tracks it left behind created new habitats for deep-sea organisms, which congregated in its wake to feed on freshly revealed nutrients. In this way, the trawler shaped the abyssal plains in cycles that may have lasted centuries. Further analysis of seafloor disturbances indicated the presence of multiple trawlers moving across the plains following ancient migratory patterns. Some tracks were years old, others decades. A few seemed to have been forged centuries prior, still faintly visible beneath layers of accumulating sediment. These overlapping paths suggested that trawlers had existed long before human observation and had likely played a central role in shaping deep-sea ecosystems across geological time. The magnitude of this revelation rippled across the scientific community. If a creature so large could exist undetected on the plains, then what else might dwell in the deep, undisturbed by human presence? The serpent, the heartback, the cathedral, eel, and the mantle each represented a unique adaptation, yet the trawler represented something more ancient and foundational, a keystone species upon which entire ecosystems depended. The most compelling question emerged from patterns in the trawler's migration. Why did these giants follow consistent loops and circuits across the abyss? What guided them? The plains themselves held no obvious landmarks. But chemical sensors on the probe detected faint gradients in mineral content, possibly created by deep tectonic processes. Some researchers speculated that trawlers navigated by following these gradients, moving in harmony with slow chemical tides produced by shifts in the Earth's crust. Others believed the trawlers communicated indirectly through sediment disturbances, each sensing paths left by predecessors. Their movement, therefore, might reflect a deep communal memory embedded within the very structure of the ocean floor. As speculation grew, one truth became clear. The existence of the Hadal trawler did not simply add another organism to the catalog of deep-sea life. It forced a complete reconceptualization of the abyss. No longer could scientists view the deep as a silent void punctuated by rare marvels. Instead, it was a dynamic realm filled with life forms that operated at immense scales of body, time, and space. The giants discovered in the trenches and volcanic rifts were extraordinary. Yet the trawler revealed that the abyss was capable of sustaining creatures beyond even those extremes. A world where the sea floor itself might be alive. Still, the greatest mysteries remained. The 5 known giants represented only the fraction of life visible by accident. The deep had offered glimpses through malfunctions, seismic disturbances, volcanic eruptions, and lucky paths of passing machines. If so much had been revealed unintentionally, what did the abyss still conceal beneath layers of pressure, darkness, and time? The discoveries collected from the serpent, the harpback, the cathedral, eel, the mantle, and finally the trawler formed a mosaic of life so vast and varied that even the most imaginative theories of deep ocean biology struggled to capture its full scope. Yet, as scientists assembled these findings, another pattern began to surface, a pattern not defined by individual creatures, but by the unseen structure of the deep itself. The ocean's most profound regions had not produced these giants randomly. Their existence reflected deeper forces, ecological corridors, and geological systems that shaped evolution in ways completely foreign to the sunlit world. Researchers realized that the deep sea must be understood not as a single ecosystem, but as a layered assembly of habitats, each driven by different combinations of pressure, chemistry, heat, and geological motion. The serpent thrived in narrow rift valleys where tectonic energy created transient warmth. The harpback lived in open trench basins where resonance traveled cleanly through water. The cathedral eel ruled isolated caverns carved by ancient geothermal flows. The mantle dwelt in volcanic chaos using fire itself as a guide. The trawler drifted across the plains, turning the slow accumulation of marine snow into an energy source powerful enough to sustain a living landmass. These organisms did not exist in isolation. They represented evolutionary solutions to environmental extremes layered across the ocean floor. And the deeper researchers looked, the more evidence they found suggesting that even larger and more complex forms might remain hidden beyond observation. Sonar surveys taken years prior revealed displaced water masses so massive and diffuse that they were initially interpreted as shifts in underwater topography. These displacements moved over spans of years, not hours, implying something immense and slow traveling through the abyss. Re-examined under the lens of modern discoveries, the data suggested the possible presence of organisms even larger than the trawler's creatures, so vast and soft-bodied that sonar waves simply passed through them undetected. The possibility raised more questions than answers. What could sustain such gigantic organisms? Would they feed on chemical gradients, microbial clouds, or the drifting remains of dead creatures accumulating over centuries? Did they anchor themselves deep within trenches, or move freely through the void like drifting continents? Their existence remained hypothetical, but the evidence hinted at a deeper layer of the abyss, one populated by titans hiding in the folds of geology. Other anomalies supported this view. Long-term chemical studies detected cyclical changes in oxygen consumption across certain trench regions, as though something immense breathed in rhythms far too slow for surface-dwelling animals. These cycles repeated predictably every few months and affected water masses stretching across kilometers. Such a pattern could only be caused by biological processes on an enormous scale. Equally mysterious were distant low-frequency acoustic pulses, recorded intermittently throughout the Pacific. These pulses bore no resemblance to whale songs, seismic rumbles, or volcanic activity. They rose and fell in harmonics that suggested purposeful modulation rather than random noise. Some pulses matched those recorded near the harpback years earlier, but others were far deeper, resonating like the slow tolling of ancient bells echoing across the ocean floor. The pulses traveled thousands of kilometers, unwavering through the darkness. No known animal could produce sound of such scale. Yet the deep had already revealed creatures that defied expectation and logic. The possibility that some unknown colossus might communicate through these deep ocean frequencies no longer seemed implausible. As the evidence accumulated, researchers began to see the abyss as a vast, interwoven world where giants ruled not through dominance but through slow, persistent existence. Each creature influenced its environment in ways so subtle and prolonged that entire seafloor landscapes could be shaped by their movement. A trawler might alter sediment flows for centuries. A mantle could change heat distribution near volcanic arcs. A harpback might send resonant pulses that guided others across basins. A serpent weaving through rifts could stir chemical currents that nourished distant colonies of life. Life in the deep was not chaotic, but patterned through relationships measured in decades, centuries, and geological epochs. By now, it had become clear that the giants discovered so far were only representatives of a much larger system. Much like the mountain ranges and river networks on land, the deep sea seemed to host interconnected biological routes, highways of darkness where pressure and chemistry shaped movement. Some creatures followed these routes systematically. Others remained fixed, occupying strategic points where heat or minerals created stability. The realization that the ocean floor itself might contain living structures further expanded scientific imagination. Some sediment ridges, long thought to be geological, appeared to move imperceptibly over decades, suggesting organic qualities. While no direct evidence confirmed this speculation, researchers acknowledged that the abyss held enough mysteries to leave the possibility open. Yet despite these revelations, the greatest challenge remained unchanged. Human technology was limited. Cameras illuminated only tiny pockets of darkness. Sonar lost clarity in soft-bodied organisms. Pressure crushed equipment before it reached the deepest fissures. Most scientific knowledge of the deep remained shaped by faulty instruments, lucky encounters, and fragments of information. Every known giant had been found by accident. None had been deliberately observed in full. None had been studied over time. None had been tracked long enough to reveal their full-range behavior or population structure. This truth humbled researchers more than anything else. It suggested that the deep was not merely unexplored, it was actively unknowable, a world not meant to be fully revealed, a world vast enough to hold secrets indefinitely. Each new discovery brought fascination, but also reminded scientists that the abyss has existed for hundreds of millions of years without human presence. Its creatures evolved in silence, shaped by pressure, darkness, and geological fire long before humanity rose to prominence. Their lives intersected human awareness only in rare moments when technology stumbled into their world. As researchers compiled the findings of the third chapter of Discovery, they were forced to accept a simple reality. The deep ocean is not a realm waiting to be explored. It is a realm that allows glimpses only when chance and circumstance align. The giants that have been seen are only the fraction that intersected human paths. Countless others remain hidden in unseen trenches, silent caverns, and cold plains beneath perpetual night. The stage was set for the final chapter of inquiry, a chapter not of observation, but of understanding. Scientists no longer asked only what lived in the deep, but why such giants existed, how they fit within the planet's ancient architecture, and what secrets still lay untouched in the farthest reaches of the abyss. For in those unseen depths there are shapes that have never felt the touch of light beings whose existence predates continents, creatures whose movements leave traces across geological time. And even with everything discovered so far, these truths were only the beginning. The more evidence scientists gathered from the encounters with the serpent, the harpback, the cathedral, eel, the mantle, and the trawler, the more they realized that the greatest mysteries of the deep were not tied to individual creatures. Instead, these encounters pointed toward a truth far more expansive. The deep ocean was not a void, but an entire world shaped by forces invisible to human experience, governed by rhythms too slow for human senses, and inhabited by beings too vast and too ancient for conventional biology to contain. Each discovery had been an accident, an interruption of the deep's natural silence by a brief intrusion of human technology. Cameras had flickered on at the precise moment a creature passed. A volcanic eruption had illuminated a drifting organism. A malfunctioning drone had brushed against a giant hidden in shadow. These moments were fragments, glimpses allowed by circumstance. They were not invitations, they were exceptions. This understanding forced researchers to confront a new question. If the deep reveals itself only by accident, what else lies hidden in its darkness? What exists in the miles of water that no light can penetrate, in the trenches that drop deeper than the height of mountains, and in the hidden networks of lightness? Fissures that run beneath the ocean floor. The known giants already painted a picture of immense ecological diversity across the Hadal zones. But these giants represented only the life that intersected with human observation. Many more likely existed in places beyond reach or detection. One of the first clues came from regions known as the interstitial abyss, the vast empty expanses between trenches. For decades, these plains were believed barren, lacking the mineral richness or geothermal energy necessary to sustain large life. But after the discovery of the trawler, scientists revisited these regions and found subtle signs of disturbance, faint arcs in sediment temperature shifts, too slow for normal currents, and acoustic distortions suggestive of large soft-bodied organisms drifting through the darkness. These disturbances hinted at the existence of creatures that moved with such slowness and softness that sonar barely registered them. Their bodies might be gelatinous or diffuse, absorbing sound rather than reflecting it. They could drift for decades, propelled only by the steady push of deep currents feeding on sparse microbial clouds suspended in the water. If such creatures existed, they could reach sizes surpassing anything known, floating through the abyss like living clouds, never leaving enough trace for instruments to capture. Beyond the plains, the deepest trenches held even greater secrets. Here, narrow vertical fissures extended deeper than any submersible had ever traveled, dropping into pockets of pressure so great that water itself behaved differently. Instruments failed in these depths, readings became unreliable, and probes lost connection without warning. These silent pits could harbor organisms unlike any seen so far, adapted not only to the crushing pressure, but to absolute stillness. Chemical samples taken near the entrances of these fissures showed faint traces of biological activity, but no organisms matched to the signatures had ever been found. The traces indicated complex metabolic processes, the kind associated with large, slow-living entities capable of altering their environment without moving far. Some researchers theorized that such organisms might be nearly stationary, anchoring themselves within the fissures like massive living pillars, drawing nutrients from mineral-rich water flowing upward from the crust. Even more enigmatic were the rhythmic chemical pulses detected throughout the deepest zones. Sensors recorded periodic rises and drops in dissolved oxygen levels and chemical concentrations patterns, too steady to be random and too vast to be caused by small organisms. These changes were slow, taking weeks or months to complete a cycle, giving the impression of immense beings inhaling and exhaling through processes unknown. If true, these creatures could be hundreds of meters or even kilometers in length, existing in near total immobility, their bodies merging with the geology itself. Acoustic anomalies added another layer of mystery. Low-frequency sounds traveled across entire ocean basins, with harmonic patterns that implied biological origin, yet no known creature could produce them. The pulses rose and fell in deliberate sequences as though forming a language beyond human interpretation. Sometimes these pulses overlapped as if many voices called through the depths in unison. Other times, they came from a single point, echoing through trenches with haunting clarity. Some speculated that these sounds were produced by the harpback species communicating across distant trenches. Others believed the calls belonged to unknown entities, far larger, perhaps entire congregations of giants singing through the abyss. Whatever their source, the sounds indicated coordination or awareness among the creatures of the deep, a form of communication shaped by pressure and distance. Other mysteries lay in the drifting anomalies detected by satellite altimetry. The surface of the ocean rose and fell in patterns that corresponded to massive unseen bodies moving far below. These shifts were subtle, a few centimeters at most, yet they spread across kilometers, forming trails that moved slowly over time. Such anomalies could not be caused by geology or currents alone. They suggested the presence of giant organisms whose buoyancy or mass displaced water on a scale detectable even from orbit. Equally puzzling were the faint distortions of gravity measured in remote regions. Though tiny, these distortions were consistent and moving. Only a mass large enough to influence the surrounding water would have such an effect. If these signatures were biological, they implied creatures so vast that they rivaled the scale of small landforms. Scientists realized that each category of anomaly represented not random noise, but potential evidence of life that had never been witnessed. The deep held hunters, sentinels, drifters, grazers, and beings that may have existed for millennia, without leaving more than the faintest chemical or acoustic trace. The deepest question then emerged. Were these creatures aware of one another? Did they interact? Did they shape their environment the way the trawler reshaped the plains, and the mantle influenced volcanic zones? Patterns in data hinted at coordination. Disturbances in one trench sometimes preceded changes in another, as though something had traveled between them. Acoustic pulses often appeared in sequences across thousands of kilometers, suggesting long-distance signaling. Even chemical fluctuations aligned across regions separated by entire ocean basins. Nothing about these patterns was simple. Everything pointed to a biosphere more interconnected than any on land. This notion led to the most profound question of all. Could the giants of the deep possess some form of intelligence? Not intelligence as humans defined it with tools, language, or technology, but a different kind shaped by slowness, by scale, by distributed neural systems. The harpback with its resonant arches, the mantle with its surface-wide sensory network, and the trawler with its decentralized neural clusters all demonstrated non-traditional forms of cognition. If such creatures communicated across trenches through sound chemical signals or changes in water pressure, then their world was not only populated, but connected. And if they were connected, then the deep might hold structures of life functioning on scales far beyond human comprehension. These possibilities shaped the final reflections on the abyss. The ocean did not conceal life accidentally. Its depth, pressure, and darkness created a world where concealment was the natural state. The creatures that lived there did not hide. They simply existed beyond the reach of human tools, senses, and imagination. The 5 giants discovered by accident were only the beginning. They were ambassadors, not anomalies, representing a realm filled with beings shaped by forces that humanity had only begun to understand. What the depths still hid was not emptiness, but abundance, vast, silent, and ancient. As the scientific community absorbed the implications of these discoveries, it became increasingly clear that the deep ocean was less a frontier and more a separate world with its own laws of existence. A world that did not rely on sunlight or surface-driven cycles, a world shaped by pressure, gravity, slow chemistry, and geological breath. A world where life unfolded at a pace so slow and so ancient that human observations barely scratched its surface. Every creature discovered so far had been revealed only because of chance. A flicker of volcanic light, a malfunction in a drone, a stray movement through a trench. These encounters were moments when 2 worlds brushed against each other. They were not windows into the abyss, but reflections briefly cast before darkness reclaimed them. This realization forced scientists to consider an even deeper truth. If the giants discovered were visible only by accident, then most of the life in the abyss would remain unseen forever. The limitations were not technological alone. They were fundamental. Human senses and machines were designed for a world of air and sunlight, not for a realm where light cannot travel and pressure crushes even the strongest materials. Patterns uncovered from vast archives of data highlighted the gulf between what could be observed and what existed. Satellite readings hinted at drifting masses far below. Acoustic monitors captured harmonic pulses echoing across entire ocean basins. Chemical sensors registered the slow respiration of beings too large for any camera to capture. Gravity measurements revealed subtle distortions that could only come from immense moving bodies. Taken alone, each anomaly might have been dismissed. Together they formed a tapestry of hints, evidence not of a single unknown species, but of an entire hierarchy of life hidden beneath pressure and silence. The question that rose above all others was simple. How large could deep-sea organisms grow when liberated from the constraints of sunlight-driven ecosystems? When freed from the need for speed or structural rigidity? When existing across centuries rather than years? The trawler provided one answer. But deeper still, in the silent sinkholes and fissures in the unlit caverns carved by ancient tectonic movement, there might be beings hundreds of meters long or larger. Creatures whose existence blurred the line between biology and geology. The abyssal world did not evolve around predation or rapid motion. It evolved around endurance. Beings there grew not upward but outward, integrating with sediment, with minerals, with water itself. Some may have formed networks connecting distant regions through chemical or acoustic communication. Others might have slept for decades, rising only when shifts in pressure or temperature awakened them. Some may have fed on chemical gradients so faint that no surface organism could survive on them. Others might have consumed only the slow fall of marine snow, accumulating across eons. Such possibilities pushed the boundaries of science. They required understanding life not as a competition for energy, but as a negotiation with scarcity. not as a rush to reproduce, but as a slow weaving into the environment, not as individuals, but as integrated systems. The deepest question was whether the giants of the abyss possessed awareness, not awareness in the human sense, but a sensitivity to their world so refined and so ancient that it constituted a form of intelligence. The harpback felt vibrations from distant trenches. The cathedral eel sensed electromagnetic changes in mineral structures. The mantle reacted to the earliest signs of volcanic shifts. The trawler interpreted chemical gradients that spanned kilometers. Each creature demonstrated perception deeply tied to the architecture of the planet itself. This suggested a form of life that was not merely adapted to Earth, but intertwined with it. Their senses aligned with the planet's own rhythms. Their movement mirrored cycles in geology. Their existence blended with the chemistry of the crust and mantle. If such beings communicated, then their communication would span years or centuries. A single pulse traveling across the ocean floor might be answered long after its source had moved. A chemical plume released in a trench might reach another species only after drifting for months. Their world was slow, connected, vast beyond measure. To humans, such a world was foreign, but to the giants of the deep, it was natural. They lived in a timescale that dwarfed human civilization. They moved at a pace that matched tectonic drift. They survived changes in climate and continents with minimal impact. They existed beneath storms, wars, extinctions, and eras without ever rising toward the light. The more scientists learned, the more they were humbled. Humanity had mapped the sky before it mapped the deep. It had measured the temperature of distant stars before it understood the rhythms of its own ocean. It had assumed that the deep was empty because the deep did not reveal itself quickly or loudly. But the discoveries laid bare a truth as old as the planet itself. The ocean holds its secrets in darkness, not because they are few, but because they are immense. The deep is not silent, it speaks in frequencies humanity cannot hear. It is not empty, it is full of life that does not move in ways that cameras can capture. It is not barren, it is fertile with forms shaped by pressures that would shatter the bones of surface creatures. And what the depths still conceal may never be known in full. Not because of ignorance, but because of scale. The abyss is too vast, too deep, too slow, too ancient. The giants living there do not interact with the surface world. They have no reason to approach the light. Their domain is pressure, darkness, and time. The 5 giants discovered by accident were not anomalies. They were representatives of an unseen kingdom older than continents and quieter than stone. The serpent weaving through rifts, the harpback resonating across basins, the cathedral eel guarding its cavern, the mantle drifting through volcanic fire, the trawler reshaping the plains. And somewhere deeper still, beyond trenches and fissures, beyond the reach of any machine lie beings of unimaginable size waiting in perfect darkness. They are not hidden, they simply exist where human senses cannot follow. The ocean keeps them, and the darkness keeps the ocean. And in that darkness, the greatest secrets of Earth rest untouched by time. We upload new videos every single day, so make sure to subscribe and turn on the notification bell so you never miss what's next. If you enjoyed this video, don't forget to leave a like, it really helps the channel grow. Tell us in the comments what you'd like to see next, your ideas might be in our next upload. Thank you so much for watching and for being part of our community. Stay tuned, stay curious, and we'll see you in the next video.